Let us consider the implementation of delete at begin, that means the first node. So visually what we need to do is we need to delete this node, the first one, okay. And if the head becomes, if the head happens to be empty or null, then we don't have to do anything, and we must not do anything. We must not dereference the null pointer. But if it is non-empty, then what will we do? So naturally head has to move to the second node, but before moving head to the second node, we can position a pointer at the first node, and then we can move the head to the second node, and then we can simply call free on this node, and we will be done. Okay, so that will be our approach. Before moving head to the next node, we will of course save the pointer to the node to be deleted in some pointer, and then we can delete it. So it is quite simple. So here is the pseudocode. So first we tackle the empty case. If head is null, we simply return the head as it is. Basically we are returning null because we have to return the new head. Okay. So this approach is quite often used, that if in some cases error or simple success cases, we do the thing and we return. So we don't have to write if then else, and we don't have to nest too many level to the right. Although this approach leads to multiple return points, one is return here and second return would be at the end. So that's okay. But otherwise this approach allows indentation to the right and nesting of if then else clauses. So if head is null, it is tackled all here, and we proceed and we come here only if head is non-null. If head is non-null, we just store the pointer to the node to be deleted. So this is like p underscore node is the ptr which we talked of. We move head, so head starts pointing here, and then we free this node. And at the end, possibly we should add return head here also. At the end of the pseudocode, I should add return head. So maybe I can add it right away. So basically what I'm saying is that we can return head here also. That makes the code kind of complete. Okay, so that's the pseudocode, and here is the code. The code is properly done. So it takes delete at the beginning, so it takes the head and it returns the new head, and it is very much parallel to the pseudocode. In this case the pseudocode was quite accurate. The only little thing is there is some debug traces added, that which node am I deleting. Okay, so and in the driver code, in the test code, we are inserting 4 elements and we are deleting 5 elements. Okay, because we want to test what happens if we are deleting from a empty list. So let's just run it and see. So we want to compile the appropriate file and we run, and you can see that this was originally the list, then we deleted a node, so 40 got deleted and this was the content, 30 got deleted, this was the content, 20 got deleted, this was the content, 10 got deleted, empty was the result. And then we tried another delete, but this time we didn't delete anything because it was null, so we just returned. So nothing was deleted, but no untoward thing happens. In fact, you can run it in valgrind. So you can say valgrind -- leak check equal to yes, -- tool equal to mem check, and you will see that 5 allocs, 5 frees. So it is kind of the perfect output. There are no errors, 0 errors, and allocs is equal to freeze. There is no leak. So that's the perfect code.